Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see some concepts related to single linked list. The prerequisite for this video is you want to know about hoops concept. Okay, if you don't know about hoops concept, just go back and watch my Python playlist in which I have given the hoops concept in detail, and also I will give in a description. And also, you want to see about the introduction video of this linked list. Fine. There's a start. See here, there are set of operations like we are going to see about node creation. So this is the structure, just about the structure of the linked list, a single linked list node, and then conversion of array into a linked list, traversal and printing, insertion and deletion, where we have set of positions, right? Now, first of all, how to create a node in a linked list? Okay, in single linked list, we have only two attributes. What are they? One is value and another one is next address. Okay, so this is the structure of a node, single node in a single linked list. Okay, now to create this node, what are the things we want to keep in our mind? Okay, first of all, we need a data. Okay, next we need a address of the next node. Right. So we are going into the what? Into a user defined data type. User defined data type. Always in data structures, we are going to use a user defined data type rather than the inbuilt data type. Okay. During these usages, you will clearly understand how the data structures are made and implemented. You can also use your own data structures, right? Now, let us see about this data structure. See here, class node. I'm creating a class. Okay. Inside this, I'm going to create a constructor. Why I'm creating this constructor? Just to initialize data member values for data and address. Let me take data. Data is equal to -1 default value, and then the next address. Next address will be what? Say none. Okay. Now constructor is ready. After this constructor, inside self dot val is equal to data, because val is the attribute, is a data member, and then next, sorry, self dot next is equal to next address. That's it. Can you understand this? Yes. By using this is our blueprint. Now, this is our blueprint for each and every node. By using this blueprint, we can create n number of objects. That is what? A node for the linked list. Yes. So how to create an object? Obj object is equal to object name is equal to class name of. So class name of, you can give this data and next address. You may not also give. Okay. If I give 10, I will be creating a node in which value is 10 and next address is none. If I just give node alone, I am going to create -1 and none. If I give node of 10 comma some address like 200, then I am going to create here 200, here 10. Can I understand now? Yes. That's why we are using this default argument. Fine. Now we are going into the conversion of array into a linked list. Okay. How to convert an array into a linked list? Okay. Let's consider this array. Now see here, if I give this as our input, I want this linked list as our output. So how to do this? First step. The first step is we want to check whether the user given a valid array. That means array which has some elements. So how to check it? If len of ARR is greater than 0, that means we have an element, right? If we have an element in an array, then what is our first step? We want to create a node for this 0th in this element, 0, 1, 2, 3, 4. For this 0th in this element, right? So how to create a node? I have already told you we want to create an object for that class. What is the class name? It is node. So temp is equal to node of, what is the value? It is 1. 1 is stored where? Array of 0. That's it. Now always my linked list first node is called what? Head. Head always points to what? The first node of the linked list. So I want to keep this as our head. So head is equal to temp. Okay, the first step is over. Now we want to continue this step for each and every nodes present in that, for each and every elements present in that array. Now I want to take this 9 and I want to create a node, then I want to create this 7, then 3 and 5. So I want to put a for loop for I in range of from 1 to len of array. Yes. Now after this, first step is to create a node. So how to create a node? Temp is equal to node of arr of I. Here you may use any variable here. It is not mandatory to use temp. Okay, fine. The next step is we have successfully created. Initially we have 1 and none. Now we have created what? We have successfully created node for 9 none. Now what is my next step? I want to say this is 200. The address is 200. I want to put this address here, right? So replace this address here. Okay, replace it. How can I replace it? Let's see here. Head dot next is equal to temp, because this is head, right? And this is temp. By putting head dot next is equal to temp, I can link them. Yes. Okay, fine. Okay, again this will be continued. Now I will take this 7 is created as node. Now again doing this process will leads to what? Head dot next is equal to temp, which means this 200 again replaces what? Let's take this as 300. Then it is replaces what? 300. A node is connected here, but we don't want node to connect there. So what is my observation here? I don't want to take this head as next. I want to move this head here. Then I want to connect this none as 300. So I want to move this head here such that head dot next, this none will be replaced as what? 300. But whether it is a correct, always we don't want to move this head. This head should point where? At the first node. So moving this head is unnecessary. Then how can we do this? This here, current is equal to head. Take another variable, and instead of this head replaces current, and then current is equal to current dot next. That's what we have done here, right? We are just moving one by one. Now come up with the observation. Initially it is 1 and none. Again 9 is created, 9 and none. Now this is replaces what? Say this 200, then 200. Yes, so link is created now. Then current is initially here, right? Now current will be back here. Current is equal to current dot next. Again a node is created 7, which is none. Again this none is replaces, say this is 300, then this address. Now current will be replaced where? Here. Like that we will go up to what? 3 and then 5. That's it. So my single linked list is constructed from a given array. Can you understand this, right? So this is the this conversion of array into a linked list. Now the next procedure, the next operation is printing. How to print a linked list? Okay, let us take the same linked list. Now I want to print, what is my output? 1, 9, 7, 3 and 5. So how can I print it? Okay, initially I want to print 1. So I want to print what? Head dot val. Okay, then I want to move this head here now. Here. So we don't want to move head because head is the first reference, right? So I will store this head in another variable. Now while up to which we want to go and print, up to I reaches this none, I want to move, right? So while current, which means while current is not equal to none, I want to go and print it. So just go and print current dot val, and then current is equal to current dot next. Just move on. First my current is here, print, and the current is here, print. Next, 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 next. Now it terminates. Can you understand this? Now here we have one edge case, like we want to insert a code here. What's the code? It is like, if there exists no node, if there exists no node in the linked list, which means if head is none, in those time what should we do? Print empty list. That's it. Then return to the function call. That's it. Can you understand this? Right? Now next one is insertion. We are going to see about insertion. Fine, let me take the node. Okay. Now just see here, in insertion we have at start, right? First we can see about start. Let us take, we want to insert a node value whose value is 10 at the starting of the linked list. Okay. Now what are the procedures to insert this 10 at the start? The first procedure is to create a node for this value 10. So how to create a node? It is so simple, right? Temp is equal to node of 10. That's it. So I have successfully created what? A node whose value is 10 and next is none. Fine. Now the next step, what should I do? I should convert this none as what? 100, because 100 is the what? Address of the head, right? Now this should be the first step. So its next should be the head. So temp dot next is equal to head. You may also give here 10 comma head. Instead of these two lines, you can also give temp is equal to node of 10 comma head. This is also correct. Instead of these two lines, you can also give like this. Okay. The next step is, now we have successfully connected these two here. Okay, but still the starting point is here, right? So take this head and move on here. Now head is equal to temp. That's it. Can you understand? Yes. Now here also we can meet a edge case. What is the edge case? If there exists no node, no node. If there exists no node, then what should we do? We should do like, first check if not head. If there is no head itself, that means there is no node. Then we want to insert that node and we want to make that node as what? Head node. Head should point to that node. So directly make head is equal to node of, just put that value. That's it. And then return head. So this you should do at beginning. This should comes here. Here. Now hope you would understand, right? Now we can go for insertion at the end. This start. Okay. Now we can go for insertion at end. So see this example. We have same linked list, but we want to insert a value 10 at end here. So what is the procedure? The first step is to create a node for this value 10. Sorry, value 10. So temp is equal to node of 10. Okay, now I successfully created a node whose value is 10 and next is none. Fine. Let me take this address as 600 maybe. Okay. Now where should I connect this new node? I should connect this new node here, right? A link should be connected here. So I want to make this none as 600. That is my goal. So to make this as 600, first I want to traverse and reach this node, right? Okay. What is the special attribute that this node has rather than all these nodes? This node has a none at it next. So we want to traverse one by one up to where the current node's next is none. So while current dot next, while the current dot next is not equal to none, I want to traverse. That's it. Current is equal to current dot next. Initially, I want to take the current as what? Head. Current is equal to head. This is an important step. Now, after this, what should I do? I should replace this none as what? 600. So replace it. Current dot next is equal to what? Equal to a newly created node temp. That's it. So simple, right? That's it. Okay. Now it's time to discuss about the edge case. What is the edge case that we face here? Here also we face an edge case where we don't even have a node. We don't even have a node, which means if head is equal to none. In this scenario, what should we do? Head is equal to node of just put 10 and return the head. So this, now inserted position. See here, we want to insert the value 10 at the position where at the second position. So the value that comes here. Okay, the basic idea here is, see here, see this carefully. 1, 9, 7, 3, 5. So I want to insert where? At this point. So create a node for 10 and make this 10 to point towards this 7 and this 9 to points towards this 10. And it automatically removed, right? Now automatically 10 is inserted. So this is the beauty of the linked list. You can insert or delete easily, unlike the array, right? So the first step is we want to reach this node so that we can easily insert the next node, right? Okay, first step is to reach this node. How to reach this node? Fine. How many steps we want to reach this node? We want only one step. Position is 2. So I can say while position -1 is greater than 0, or else I can also put position is greater than 0. Whatever. I want to do position minus is equal to 1 and also current is equal to current dot next. Up to this I want to traverse. Okay, but sometimes we may face some edge case, right? Like here only 4, but if they give position as 10, then you will reach where? You will reach to null. First of all, you will reach null. Then whether none dot next is valid? No, this is an error. So what should be careful? We should be careful like and current. We should have these both condition is true. Then only we want to do this step. Can you understand this? Right? Okay. The next step is we reached here. Now we want to create a new node. Okay, how to create a new node? Let me write here first of all. Now, how to create a new node? It's simple, right? Temp is equal to node of what is my value? It is 10. Okay, that's a new node created 10, and here is none. Okay, now what should I do? I should make this 300 to point where? Let me take this as 600 to point 600, right? But if I point it towards 600, then I will lost this node, right? This node address I will lost. So first I want to update this none as 300. Then I want to update this as what? 600. So what I am doing now? Temp dot next is equal to what? This address. What is this? Current dot next. Current dot next. Yes. Now it's time to update this 300 as 600. So current dot next equal to temp. That's it. This is connected here. This is connected here. That's all. That's all about this code. Yes. And if this current is null in this point, if current is equal to none, then what should I do? Okay, this is the edge case, right? If that's the case, then we have no position to insert. So I just print invalid position like that. Just print invalid. That's it. And then return it. We don't want to insert anything. Just print the invalid position, because if they give position as 10, it will stop at where? None. So currently the current will be none. Whether we can insert any values there? No. That's why we are using this as our base case. Fine. Now, next we are going to see about the deletion operation. Deletion. Deletion at start. First, we are going to see about deletion at start. Okay, this is my linked list, right? Now, inside this linked list, I want to delete this node. I want to delete this node. Okay, how to delete this node? First of all, I want to shift this head here. If I shift this head here, whenever I am traversing, I will traverse 9735, 9735. That's it. Okay, but we want to free up this memory. What am I free up? We want to erase this node from our memory. So to erase this from our memory, we can use in C++ we use free, but in Python we use del. Okay, it's a function to delete a object, whatsoever the object. It may be any data type. We use del. Okay. First step is to take the head to next. But to delete this, we want reference here. So I will take temp is equal to head. Then I want to check whether if go to head is equal to head dot next. Okay, I moved. Now it's time to delete the temp. Just delete temp. That's it. Fine. But here our edge case is if not head. If there is no head itself, then what should we do? We should do like just leave it. Don't do anything. Just leave it. Why we are leaving it? Because there is no elements to delete itself. Then where I can go and delete some nodes, right? So this is our code for deletion at first or deletion at the start. Okay. Now let's just see about deletion at the end. Okay. Deletion at the end. So we want to delete this node. To delete this node, first we want to get into this node. So my current should point here such that I can remove this connection, right? If I remove this connection, it will be deleted. So first I want to go here. So current is equal to head. While current dot next is none. Currents next is none. To that I want to traverse. Right? After traversing, what should I do? I should remove this link, right? Before removing this link, I want to get the reference of this point. So temp is equal to current dot next. I got a reference. Now current dot next is equal to none. Now it's time to delete. Delete the temp. That's it. So simple, right? Now it's time to see the edge case. In some edge case, like we don't even have a single node. If we don't even have a single node, what should we do? So let me write here. If not head, then what will do? Just return none. Fine. So this is one edge case. And another edge case is if not head dot next. If there not even exist two nodes, which means just one. So here is my head. In this case, we want to delete this one, right? This is our first node. Also, this is the last node. So we want to delete this one. So at this time, what I am going to do? Del head and return none, because there is no element exists. So these are the two edge cases we want to write before doing this steps. Can you understand this now? Yes. Now at last, we are going to see about deletion at position. How to delete at a position. Okay. Let us take the same linked list. Now, in this linked list, if take for example, let me give position as 2, 0, 1, 2, 3, 4. Or else let me give 3. Already we done for insertion for 2, right? So 3. So I want to delete this node. I want to delete this node. To delete this node, if I connect this node with this node, I deleted this node, right? That's it. So to reach this node, How many steps we require? 1, 2. So 2 steps we need. So initially my current is equal to head. While we should have current, and also we should have what? A condition called position minus 1 is greater than 0. During this condition and also current, what should we do? Current is equal to current dot next. Just go on traverse on. Go on traverse on. Now, once I reach this point, what should I do? I should connect this with the next node. But before that, we should have a reference here so that I can delete it. So I will take the reference as temp. Temp is equal to current dot next. Okay, I successfully got the reference. Now, current is equal to, what should I do? Sorry, current dot next. Current dot next is equal to, I want to connect this to here, right? It is what? Temp dot next. Is what? Temp dot next. So temp dot next connected. So it is updated as what? 500. Now it's time to delete the temp. So just delete the temp and return what? Return head. That's it. So this is our entire code for deletion at a position. But here we may have some edge cases, like if we don't even have a current pointer here we don't even have a current pointer, like if not current, then what should I do? I should just return the head, because there is no node at the given position. Then what else I have to do? It is easy job, just return. If not, sometimes we have only current, we don't have current dot next. We don't have current dot next. At this point, what should I do? Just see this example. If I have 1, then 9, then 7, then 3, that's it. Okay. Sorry, we don't have 3. We only have up to 7. Now I have to delete what? I have to delete the position here. So I will stand here current. Whether we have any current dot next? No, right? We don't have current dot next. So I want to put here and not current dot next, or not current dot next. So this is my condition when I return just head, because I don't want to delete anything. Okay, can you understand this, right? So this is about deletion position. So this is all about the singly linked list. In upcoming playlist, in upcoming videos in this playlist, we can see about the code implementation for each and every process in this video, and also we can see about doubly linked list, circular linked list, and many more problems in linked list in this playlist. Thank you.